In the last lecture, we studied about the types of semiconductors, that is P-type semiconductor and N-type semiconductor, and the difference between them. Now in today's lecture, I am going to talk about P-N junction diode, then formation of depletion layer and barrier potential, then behavior of P-N junction diode in forward biasing and in reverse biasing, and finally the difference between forward biasing and reverse biasing. So students, the first question of today's lecture is what is P-N junction diode and how it is formed. So students, let us say that this pen is going to represent my semiconductor crystal. Now if this semiconductor crystal is divided equally into two parts, and the first part is doped with pentavalent impurity and the second half is doped with trivalent impurity, that means the first half becomes my N type of semiconductor and the other half becomes my P-type semiconductor. So then this semiconductor crystal is said to be P-N junction diode. So if you want to define P-N junction diode, to simply say when half part of semiconductor crystal is doped with N-type and the other half is doped with P-type, then this newly formed structure is called as P-N junction diode. See here, you understood the meaning of P and N. But what is the meaning of junction and what is the meaning of diode and why we are using this term? So basically, in this diagram you can observe if this is my P type of region, that means trivalent impurities added here, and this is my N region where pentavalent impurities added. So students, what is happening when this P type region and N region is formed, so the line along which they meet, or I can say that they appears to be joined along this line. So this line only is called as my junction. Now, what do you mean by depletion layer and what do you mean by barrier potential? See, actually the meaning of the word depletion is free of any charge carriers. But no charge carriers are present. So students, what happens when this P type and N type of semiconductor is formed? So just after the formation, the electrons from N region are attracted towards what? The holes of P region, and holes from P region they are attracted towards the N region, and that's why some of the electrons from N region and some of them from P region, they will cross the junction and they will recombine. That means electrons and holes will be diffused, and after diffusion they are going to form the neutral atoms. So basically I can say that this region will behave like intrinsic semiconductors because neutral atoms are formed. Now after this, because of losing of electrons from N region, there will be formation of positive charges towards N side, and because of losing of positive charges towards P region, there will be formation of negative ions towards P region. So basically, please do not misunderstand. This region, this is free of charge carriers. These positive charges are going to be the positive ions which is formed towards N region, and this is going to be the negative ions which is formed towards P region. But this particular region is free of any charge carriers, and that's why it is called as depletion layer. Now the question is, what happens next? What about the other electrons and the other holes? So basically students, what happens after the formation of depletion layer, because of the presence of these ions, that is positive ions towards N region, it won't allow further diffusion of holes towards N region, and this negative ions towards P region, it won't allow further diffusion of electrons from N region towards the P region. And this will behave as if there is a formation of a potential difference, and because of this potential difference only further diffusion of electrons and holes stops, and this is the reason why it is called as barrier potential. That is the potential which restricts the further movement of electrons and holes. You can see in this diagram, this is the potential difference across the junction. This is going to be the positive one, that is the higher potential, and this is going to be the negative potential. So there is a potential difference across the depletion layer. And remember, this is the unbiased condition, that is when there is no potential difference across the PN junction diode. This is the symbolic representation, and in this symbolic representation you can see here this triangular structure. This is going to represent the direction. So this is P, that is positive terminal, and this is N, that is the negative terminal. So all of you know that the conventional direction of current, that is, it will flow from positive to what? Negative region. So that's why this arrow is from positive to negative region. Now some points which you have to remember for PN junction diodes. Number one is the width of the depletion layer is about 0.5 micrometer to 1 micrometer. So here the width of the depletion layer, please try to remember, it is very small, of the order of 0.5 micrometer to 1 micrometer. Number two, the barrier potential for silicon is observed to be 0.7 volt, and for germanium it is observed to be 0.3 volt. Number three, the strength of the electric field across this depletion layer is very large. And in order to understand that, let us take one simple example. Let us talk about in germanium crystal. In germanium crystal, as per the formula of electrostatics, E is equal to rate of change of potential with respect to distance. This formula dV by dx, and here dV is 0.3 volt, that is the barrier potential across the germanium crystal. And this is going to be the width of the depletion layer, 1 micrometer, that is 10 raised to minus 6 meter. And when it comes to the numerator, capital E becomes what? 3 into 10 raised to 5 volt per meter. So students, after studying the concept of PN junction diode, let us study for what is forward biasing and what is reverse biasing. So first about the PN junction diode in forward biasing. You can see that this is the block diagram of PN junction diode, and in this block diagram, this is what my P region, this is my N region. As you know, P region consists of what? Positively charged holes as the majority charge carriers and electrons as the minority charge carriers. And in N type region, the majority charge carriers are going to be my electrons, and holes are going to be my minority charge carriers. This is the junction, and this region, that is what depletion layer. This is what the barrier potential. And one more thing which you can observe now is, here I have connected the P region to the positive terminal of a battery, and N region to the negative terminal of the battery. So students, such type of connection is called as forward biasing connection. So in short, if you want to write what do you mean by forward biasing, simply you have to write when positive terminal of battery is connected to P type and negative terminal is connected to n-type region, then PN junction is said to be in forward biasing. Now what happens after this connection? See, after this connection you can observe in this block diagram that this positive terminal and these are going to be the positively charged holes. So undoubtedly there will be repulsion, and because of this repulsion the holes will start moving towards the junction, and here you can observe that this is my negatively charged electrons and this is my negative terminal of the battery. So once again here also there is repulsion, and that's why the electron will start flowing towards this junction. So after the connection, basically what happens on both the regions, on both the sides, okay, we are going to observe that there is repulsion, and because of this repulsion the holes and electrons, they start moving towards the junction. But in the beginning it is observed that they are not in a position to cross this junction. What is the reason behind that? The reason is here. Can you observe this? Okay, this is our applied potential difference and this is the barrier potential. You can observe that the direction of the EMF, okay, in this case is from right to left, and here in this case it is from left to right. Matlab, the potential differences are anti-parallel to each other. Now if this potential difference is lower than this barrier potential, that is less than the barrier potential. For an example, let us say that, just for an example, let us say that if applied potential difference is 1 volt and this is 1.5 volt, so the electrons and holes, they don't have sufficient energy to cross this junction. Okay, so in the beginning when we apply the potential difference, and if this potential difference is small as compared to the barrier potential, the crossing of the holes and electrons won't take place, that is, there won't be any current in the circuit. But when you will start increasing this applied potential difference, so you will observe that this barrier potential goes on decreasing and hence the depletion layer. And when the barrier potential becomes equal to 0, then you will observe that the holes and electrons, they will start crossing the junction. And after that, if you are increasing the potential, okay, then I can say that the current goes on what? Increasing. About this we are going to get the detailed information in PN junction diode characteristic in coming up lectures. So students, if you want to write about PN junction diode in forward biasing, so number 1 you have to write what is the connection in PN junction diode forward biasing. The block diagram will be there. Remember, in the block diagram must represent the conventional current as well as the electron flow. All of you know that the conventional direction of current is from positive terminal of the battery to the negative terminal of the battery, whereas the direction of electron flow, you can see the electrons are flowing from this side to this side. Okay, so this is the direction of electron flow. Now in point number 2, you have to write in forward biased electrons from N side and holes from P side are pushed towards the junction, that you can observe. Number 3, because of this reason, what happens? The width of depletion layer and hence the potential barrier decreases with forward bias. So you can observe the width of the depletion layer is decreasing, okay, and so with the barrier potential. Number 4, if applied potential difference across the junction is less, that means if this potential difference across the junction is less than barrier potential, it is less than the barrier potential, then there will be no current through the junction. So there won't be any current because the majority charge carriers, they are not in a position to cross the junction. But later on, what is going to happen? If applied potential difference across the junction exceeds the barrier potential, that means if you are increasing the applied potential difference and at one point it is more than or equal to barrier potential, then what happens is the large number of electrons and holes will cross the junction. And because of this reason, I can say that the electrons and holes will recombine and so that large current will flow through diode. So students, in forward biasing, what is the speciality of the forward biasing? In forward biasing, the current is due to the flow of or due to the crossing of majority charge carriers, and because of this reason a very large amount of current flows. That is, PN junction diode in forward biasing acts as a very good conductor. Now after this, let us discuss about the reverse biasing. So here, now in this diagram, you can observe that this is the block diagram of PN junction in reverse biasing. So what do you mean by reverse biasing first? So you can observe that this is my P region, and this P region is connected to the negative terminal of the battery this time, and the N region is connected to the positive terminal. It means just opposite of their nature. If it is positive, connect it to negative. If it is negative, then connect it to positive. So such type of connection is called as reverse biasing. Now students, what happens in reverse biasing? You can observe in the block diagram that this is the negative terminal and this is the positive charge holes. So holes will be attracted towards the negatively charged applied electric field, and the same happens with the electrons. They will be attracted towards the positive terminal of the battery. Now because of this reason, the holes and the electrons, they will start moving away from the junction, and if they are moving away from the junction, so what happens? Depletion layer ka width is going to increase, and because of this increase in the depletion layer, we can say that no majority charge carriers are going to cross the junction. But when we observe, so in this reverse biasing, we observed a very small amount of current. The question is how this current comes. So basically students, what happens, you can observe these electrons are going to be the minority charge carriers in P region, and these are the holes which are the minority charge carriers in N region. So basically students, what happens, these holes are attracted towards the negative terminal of the battery, and these electrons, these minority charge electrons are attracted towards the positive terminal of the battery. But these minority charge carriers are going to cross the junction, and because of this crossing, we can say that a very small amount of current of the order of nanoampere flows in the circuit. So if you want to write about the reverse biasing, you can simply write in point number 1 what is reverse biasing. So here, when negative terminal of battery is connected to P type and positive terminal is connected to N type region, then PN junction diode is said to be in reverse bias. Number 2, in reverse bias, electrons from N side and holes from P side moves away from the junction. So they are moving away from the junction. Number 3, the width of depletion layer and hence the barrier potential increases with reverse bias. So you can observe, okay, this is going to increase and hence the same with the barrier potential. Number 4, as there is no crossing of majority charge carriers across the junction, there is no current through reverse diodes. Number 5, however, a very small current flows because of thermally produced minority carriers in depletion region. And finally, you have to write when reverse bias is increased at a particular high value, the reverse current increases suddenly. This is called breakdown diode. And once again students, I am going to discuss in detail about point number 6 in coming up lecture, that is about the PN junction diode characteristics. But for the time being, please at least you have to mention this point, when reverse bias is increased, then what is going to happen. So at a particular high value, what will be the observation? The reverse current increases suddenly. Here there was a sharp rise in the current, but here there is a sudden rise. Okay, and this is called as breakdown diode. Now finally coming to the last question of this lecture, that is the difference between forward biasing and reverse biasing. So one by one. Number 1, about the forward biasing. In forward biasing, positive terminal of battery is connected to P side and negative terminal of battery is connected to N side. And here in reverse bias, positive terminal of battery is connected to N side and negative terminal is connected to P side. That means in first point, you have to talk about the connections, how you made the connections. Number 2, in this case, width of the depletion layer decreases, whereas in this case, width of the depletion layer goes on what? Increasing. In this case, the barrier potential decreases, but here the barrier potential increases. Number 4, it acts as a closed switch. That means there is large amount of current in the circuit. It acts as a good conductor. It acts as an open switch. That means there is no current in the circuit when such type of connection is made, or very small amount of current is observed. So we can write like this also, ki current is due to crossing of majority charge carriers at the junction. Here the current is due to crossing of minority charge carriers at the junction. Here large current of the order of milliampere flows, whereas in this case very small amount of current of the order of nanoampere flows. Here the current flows from P to N side of the junction, and in this case current flows from N to P side of the junction. Finally, it acts as a good conductor and it acts as a good insulator. So students, in very short, always try to remember that in forward biasing, the PN junction diode is going to play the role of a very good conductor, because it allows the current of the order of milliampere to flow through it due to the flow of majority charge carriers or due to the crossing of majority charge carriers at the junction. Whereas in reverse biasing, it is just opposite. The behavior is just opposite. It is going to act as an insulator, and the current is of the order of nanoampere because of the flow or because of the crossing of minority charge carriers. So students, this is all for today. Goodbye.